Hello, everyone, and welcome back to Backend Radio.
Hi everyone, I am William and I am here with Olivia.
Today, we are continuing our Backend series,
In the first episode, we talked about queues.
and in the second episode, we talked about workers.
Today, we are connecting those ideas with a popular Python tool.
Exactly. Today's topic is Celery.
Celery sounds like a vegetable, but backend developers talk about it like a serious machine.
That is true. In Backend, Celery is less salad and more background task engine.
Good, so let's start simply. What is Celery?
Celery is a background task system for Python applications. It helps your app send slow or heavy work to workers.
So Celery helps the main app avoid doing slow work directly.
Exactly. That is the core idea.
Is Celery the queue?
Good question. Not exactly. Celery is the task system. It knows how to send tasks and how workers should process them.
Then where's the queue?
The queue usually lives inside a message broker.
A message broker like Redis or RabbitMQ?
Exactly. Celery uses a broker to send messages between the app and workers.
So Celery does not work alone.
Correct. Celery usually works with a broker and one or more workers.
Can we describe the pieces one by one?
Sure, there are four main pieces. First, the main application.
For example, a Django app, Flask app, or Fast API app.
Second, the task.
A task is a piece of work that needs to be done.
Exactly. Sending an email, creating a report, or processing a video can be tasks. Third, the broker.
The broker carries the task message.
Yes, it receives the message and keeps it until a worker can take it. Fourth, the worker.
The worker takes the task from the queue and runs it.
Perfect! That is the basic Celery world.
Main app, task, broker, worker.
Yes, if you remember those four pieces, Celery becomes much easier.
Can we use a simple real example?
Of course, let's use a sign-up example.
A user creates an account.
The Django app saves the user in the database.
Then the app needs to send a welcome email.
Right, but sending email can be slow.
Because the app may need to call an external email service.
Exactly, and that service may be slow for a few seconds.
So the Django app should not wait for the email service during sign-up.
Correct. Instead, the Django app sends a Celery task.
What does the task say?
It may say, send a welcome email to this user.
And maybe it includes the user ID.
Exactly. Usually we send simple data like a user ID.
Then where does the task go?
Celery sends the task message to the broker.
The broker stores it in a queue.
Then a Celery worker takes the task and sends the email.
So the user gets a fast sign-up response, and the email is sent in the background.
Exactly. That is one of the most common Celery use cases.
Why do Django developers use Celery so much?
Because many web applications need background jobs. Celery helps run those jobs outside the request-response cycle.
Request-response cycle means the client sends a request and the server sends a response, right?
Exactly.
If we put slow work inside that cycle, the response becomes slow.
Correct. Celery helps move that slow work outside the cycle.
Can we use our video generation example?
Yes, video generation is a perfect Celery example.
Imagine a user clicks a button to generate an English learning video.
The API receives a request and creates a content record.
But the full video pipeline can take a long time.
Yes, it may need dialogue, audio, subtitles, and video rendering.
That can take minutes.
Exactly. So the API should not wait for all of that.
The API can create a Celery task and return a response quickly.
Correct. Then the Celery worker runs the video pipeline in the background.
And it can update the status step by step.
Yes, for example, audio generated, subtitles generated, video rendered, and done.
So the user can see progress instead of waiting on one frozen request.
Exactly. That is a much better system design.
And much better for the user's patience.
Yes, user patience is not an unlimited resource.
Can Celery run tasks one after another?
Yes, Celery can support workflows like chains.
What is a chain?
A chain means tasks run one after another in order.
So task 1 finishes, then task 2 starts.
Exactly. For video generation, this is very useful.
First create the dialogue,
Then create the audio.
then create subtitles.
Then render the final video.
So Celery can be used for simple tasks and bigger workflows.
Exactly.
Can Celery run scheduled jobs too?
Yes, Celery can also work with scheduled tasks.
Like every morning at 9?
Exactly. For example, send a daily digest email every morning.
Or clean old temporary files every night?
Perfect example.
Is that related to Celery Beat?
Yes, Celery Beat is commonly used to create periodic tasks.
So Celery workers process tasks, and Celery Beat can create scheduled tasks.
Exactly. Nice summary.
What happens if a Celery task fails?
Celery can retry failed task if we configure it that way.
Retry means try again later.
Exactly. Retrying is useful for temporary problems.
For example, an email provider may be down for a short time.
Yes, or an external API may return a timeout error.
In that case, the worker can retry the task later.
Correct, but retries must be controlled.
Controlled how?
For example, retry 3 times, wait between retries, and mark the task as failed if it still does not work.
Because retrying forever can create more problems.
Exactly. Infinite retries are not a strategy. They are a future production incident.
That sounds very back-end.
It is very back-end.
Can Celery tasks run more than once?
They can, depending on failures and configuration.
So we should design tasks carefully.
Yes, Celery tasks should be safe to retry when possible.
Is this where idempotency matters?
Exactly. Idempotency is very important for background jobs.
If the same task runs twice, the final result should still be correct.
Perfect explanation.
Can you give a short example?
Sure, imagine a task generates a monthly report. If the task runs twice, it should not create 2 confusing reports for the same month.
It should check if the report already exists.
Exactly, that is safer.
What should we monitor in a Celery system?
We should monitor queue size, active workers, failed tasks, retry counts, and task duration.
Task duration means how long each task takes.
Exactly. If tasks are taking too long, the queue may grow.
And if the queue grows, background results may be delayed.
Correct. Monitoring helps us find problems early.
Can we add more Celery workers when the queue grows?
Yes, often we can. If there is too much work, we can run more worker processes or more worker containers.
Like adding more people to process orders?
Exactly, but we must be careful.
Because more workers can create more pressure?
Yes, more workers can mean more database queries, more API calls, and more CPU usage.
So scaling Celery is not just adding workers blindly.
Correct. You need to understand the bottleneck.
Bottleneck means the slowest or most limited part of the system.
Exactly.
If the database is the bottleneck, more workers may make the database worse.
Perfect. That is a strong backend point.
Is Celery only for Django?
No, Celery is not only for Django. It can be used with many Python applications.
For example, Flask or FastAPI?
Yes, Django, Flask, FastAPI, or even a pure Python service.
So Celery is a Python background task tool, not a Django-only tool.
Exactly.
When should I use Celery?
A practical rule is this. Use Celery when work is slow, heavy, repeated, scheduled, or can happen after the response.
Slow, heavy, repeated, scheduled, or later?
Exactly. That is easy to remember.
When should I not use Celery?
Do not use Celery for everything. If the operation is very fast and must happen before the response, doing it directly may be simpler.
So Celery adds power but also complexity.
Exactly. You need a broker, workers, monitoring, retries, and deployment configuration.
So Celery is not free magic.
No backend magic is free. It usually sends logs first and invoices later.
Can we explain a complete Celery flow one more time?
Yes, let's make it very clear. Step 1, a user sends a request to the application.
Step 2, the application creates a Celery task.
Step 3, Celery sends the task message to the broker.
Step 4, the broker puts the message into a queue.
Step 5, a Celery worker takes the task from the queue.
Step 6, the worker runs the task in the background.
Step 7, the worker saves the result or updates the status.
That flow makes sense now.
Great, that is exactly the goal of this episode.
Can we review the main points before we finish?
Of course. First, Celery is a background task system for Python applications.
Second, Celery helps move slow or heavy work outside the request-response cycle.
Third, Celery usually works with a broker like Redis or RabbitMQ.
Fourth, Celery workers take tasks from the queue and process them.
Fifth, Celery is useful for emails, reports, images, videos, external API calls, and scheduled jobs.
Sixth, Celery needs retries, monitoring, status tracking, and safe task design.
Excellent summary.
So, if you are building a Python backend and you have slow background work, Celery may be a very good tool.
Exactly, but use it with care, not by habit.
If this episode helped you, please like the video and subscribe to the channel.
In the next episode, we will talk about RabbitMQ.
What is a message broker? Why does Celery need one? And how does RabbitMQ help tasks move between the app and workers?
Thanks for listening to Backend Radio.
See you in the next episode.